Alright, hello. I'm going to demonstrate my open-ended project. Let me navigate to it real quick. And yeah, my project is an implementation of Connect 4 the game using different forms of inheritance and utilizing output options as well. Um, Toss this right here. So it all pretty much starts with the player header file. It has a destructor for just to make sure that overflow doesn't occur, and then it has the get move function, which is inherited by the other classes. There is a human player that has a piece and inherits the get move function and overrides it for its own purposes. Um, Oops, that one's good. Here is the human player CVP file, and it just gives him simple output asking for what place you would like to place your piece. Um, you play against a computer in this class, same type of deal as the human player header file, just utilizing it for the computer. And here is where some of the magic starts to happen. In the get move method, I implemented a little bit of intelligence where it checks its own piece, it checks the opponent's piece. Um, Here's a helper function that just helps it find the row, selects the row that it wants to place the piece in, and returns that for these functions. The first method that it's going to try to, or the first technique it's going to try to utilize is trying to win. This is just making sure that there is a valid move to take. If the row is valid, if the row falls in line with the helper function, it's going to drop the piece down there, and it's going to try to win with that piece. If there isn't any winning move, it's going to try to block the opponent, looking for any potential connect four that I or the certain player wants to make. And if those two kind of fall through, the backup plan for the computer is going to just prefer the center first column. That tends to be the technique within Connect 4. That's also what this person that posted this forum, I don't have their name in here, but I took a lot of inspiration from them on just implementing a computer within the game. So they both play against each other. In the game header file, there is an object. There is a board object, which the board pretty much just has all these functions that are typically used within. You gotta make sure it just checks. It's just a list of booleans that checks whether or not the game can continue, whether or not a piece can be placed there, and the game has a board object, and then of course two player objects identifying the player and then the computer respectively. Inside the game, it just makes sure that the game isn't over every time. Just the two moves rotating back and forth there. It makes sure that the game isn't over. It prints the board. It just makes sure that the current player is able to select a move. Test whether it's the player or the computer going, and it has a little bit of output handling right here. Okay, inside of main, similar thing happens. You have the human player established, computer player established with the O. It can really be any piece, but then it just goes move for move, plays the game until it terminates with the, what's the name of the function? The check win. If check win turns to false, the game is terminated and a message is brought up identifying the winner. Shoot. We go back to the rubric. What else do I have to talk about? One demo run, of course. Let's play. All right. Starting off, the best move is probably to go in the middle. It's just going to hop on top. It's able to block the winning move there. We'll try to go to the other side and see if it even gets me there. Oh, Jerry won. Oops. I let him win. Well, I'm terrible, as you can see. Let's play again. Jerry, I just named it Jerry. I thought it was funny. I think it's nice to have it, like, have a name. Just gives it a little interest. I don't know. It's able to block me there. Am I gonna lose? Yeah, I could definitely make it a little more attractive to look at. Winning move for me. Bang. There we go. We're 1-1. Unfortunately, that tie is gonna stay the way it is. No third game is gonna be played. Yeah, you saw a little bit of input validation there. No, you didn't. Here's some of that. Invalid move. Oh, that's something I can fix. So it can handle wrong numbers. Can it handle white space? Let's see. Nope. It sure as hell can't. But there you go. Not much input handling. Okay. Hope that was fun to watch. Thank you.